Okay, so this is 5.4 day 1. So we're going to look here at the formulas that we learned last week, and then that you guys saw some proofs on over the weekend in the video that you watched. So we have our different sum and difference identities there, so you can see them there listed again. So what these are going to be helpful for is that so that we can find the sine and cosine tangent values of non-unit circle values that could be broken up into a sum or a difference of a unit circle value. Okay, so we're looking at these two here. So I kind of mentioned this on Friday, but we have the sine of 75 degrees. And you might look at that and say, oh, well, what do you mean I have to find that without using my calculator? I can't find that without using my calculator because it's not unit circle. But now that we have those formulas, we can do that. So what we want to think about is we want to think about how could I break up 75 into two numbers that are unit circle values that I can then plug into the formula. So I think about how do I rewrite this 75 here, 75 degrees in this case, into two values that are unit circle values. So I can say that that's equal to the sine of, and then I can rewrite it as 30 degrees plus 45 degrees. So with the 30 plus 45 then, since those are unit circle values, when I apply the formula, all I'm doing is calculating different sine and cosines of those unit circle values. So I have the sine of one of the angles, and then I do the cosine of the other angle. And then this, for the sine formula, it's plus in between. And then I do the cosine of the opposite angle. So then I do the cosine of, I did 45 before, so now I'm going to do 30. And then I do the sine of the angle I didn't take the sine of yet, so that's 45. And so now when I've done this, now I have all unit circle values for sines and cosines, and I can evaluate. So evaluating then, the sine of 30 degrees is 1/2. The cosine of 45, square root of 2 over 2. And then plus, and then the cosine of 30 degrees, square root of 3 over 2. And then the sine of 45 degrees, square root of 2 over 2. And they both have a common denominator of 4, so I'm going to put them together as 1. And so then I have the square root of 2 plus the square root of 6 all over 4. So I've not only been able to calculate this sine of 75 without using my calculator, I was able to calculate the sine of 75 to get an exact value as well. Which, that's pretty cool to be able to get an exact value and not have to have a decimal, not have to have rounding and things like that. Okay? And so this is how we can use these formulas then to do something useful for finding the trig values. So the next one is in radian. So if I just look at this here, I'm looking here now for pi over 12. So this is where your unit circle knowledge is going to be really helpful to make this kind of go a little bit faster. And then the degrees is always easier to think about than the radian because the degrees are all integer values. They're all whole numbers, right? But then radian, we have fractions. So fractions are always a little bit more complex. And so what I like to do is I like to think in my head of what are all the different fractions over 12. And if you want, just go ahead and write them down. So if you think about the fractions that we have, our smallest one is pi over 6. So that's 2 pi over 12. And then we have pi over 4. So that's 3 pi over 12. And then we have pi over 3. So that's 4 pi over 12. And then we have pi over 2. And that's 6 pi over 12. And then all of the rest of them, because it's like 2 pi over 3. Well, that's just going to be a multiple then of the 4 pi over 12, right? So we get any multiples of any of those. So this is a little bit helpful because it makes it easier to figure out what we can do for the cosine. So I want you guys to think about that. So what could you do for the cosine here? So that you're going to think about, okay, well, how can I rewrite this as the cosine of either the sum or difference of something to get pi over 12? So go ahead and think about that and then calculate and see if you can get the answer. All right, so whichever way you decided to put it, if you did cosine of pi over 4 minus pi over 6, or if you did cosine of pi over 3 minus pi over 4, either way with your substitutions and calculations with your unit circle, you should end up with square root of 6 plus square root of 2 over 12, or maybe square root of 2 plus square root of 6 over 12, right, because addition is commutative. Okay. And so we can use those formulas then to find those values. All right. So if we take a look then at question number 2 here, question number 2 is just asking us to simplify. And so here we're just asked to kind of look at this and see if we can make it simpler. And so when you're looking at this, you can see that we have a cosine and a cosine. And then the second term is a sine and a sine. So you're like, ooh, what formula does that one look like? That one looked like the cosine formulas. So I'm going to start with that. So I'm going to put equals. So it's going to be the cosine of something. Okay, now I have to figure out if it's plus or minus. I also want to make sure that you guys recognize that this 0.96, the angles stay the same, right? 0.96 there, 0.96 here. And then we have the 0.42, and then we have the 0.42. So it's like, you know, X and Y, or U and V, or whatever you want to think about it. And then we decide if it's going to be plus or if it's going to be minus. So we look back at the formula. So what do we think it's going to be, plus or minus? So the cosine formula is always opposite, so that changes to minus. And then we just have 0.96 minus 0.45, and then we can just go ahead and simplify that. So that gives us the cosine of 0.5, oops, not 45, that should be a 0.42. I wrote that wrong. 0.42, so we have 0.54 for our answer. So we're able to simplify that into just one cosine value. All right, my mistake on number 1b, that should just be a 4. I just wrote that down wrong. A little brain fart there. So we should have for 1b root 6 plus root 2 all over 4. Same answer as number 1a. All right, so for this one here, we have 2 different angles. We have angle U and angle V. We don't know what angle U is. We don't know what angle V is. We actually don't even need to know what angle U or angle V are. Okay? Because we're given some information about these two. So let's first take a look at what we know about angle U. So I'm going to look here at this restriction. It tells me the angle U is between pi and 3 pi over 2. So if I make a little sketch of that, that's going to mean that my angle is going to be in quadrant 3. So I'm going to make my angle in quadrant 3, draw a triangle there. And then it tells me that my cosine is negative 15 over 17. So we know that cosine is adjacent over hypotenuse. So my adjacent side is going to be the negative 15. My hypotenuse is 17. And then I can see here that this is a lovely Pythagorean triple. So we fill in our missing side there from our Pythagorean triple of negative 8. And then we can use that triangle later on. I'm also going to label my angle here. So this is angle U. And again, we don't need to know what the measure of that angle is. So we're not using our calculator at all. Then we're going to do the same thing for angle V. But let me make one correction for angle V. There was a little typo. Switch the 4 and the 3 around. So make the numerator 3 and the denominator 4. Otherwise, it doesn't make sense. So we'll make our numerator, whoa, that was really fat pen. Make our numerator a 3 and our denominator a 4. Because the hypotenuse has to be bigger than the leg, right? Okay, so let's first look at our restriction here. And so this one is restricted to 0 to pi over 2. So that means we're going to be in quadrant 1. So I draw my triangle in quadrant 1. And then I'm looking at this sine. So sine is opposite over hypotenuse. So my opposite is 3, my hypotenuse is 4. And that's going to be angle V inside there. Well, this one, it looks like it might be a Pythagorean triple, but it's not, right? So we need to find the missing side. And so you don't need to show the work for this. You can do this work in your head. So if you would like to do it in your head, that's fine. If you want to write it down, a squared plus 3 squared equals 4 squared. To solve, you can do it that way as well. Okay, totally up to you. All right, so go ahead and find that missing side. All right, so we have our square root of 7 there, and that's angle V. And so now all we have to do is we just have to apply that formula. So we're doing the cosine of U minus V. So we know that's cosine times the cosine plus, it's the opposite, right? And then it's the sine and the sine. All right, so I just plug in the information now by reading the diagram. So be very careful with when you're reading the diagrams. Make sure that you're reading the U diagram for the U problems and the V diagram for the V stuff, because it's really easy to get mixed up. So maybe take your finger and like follow on the diagram, point to this diagram, and then point to the other diagram, and then point to the other diagram, and point to the other diagram, okay? So we're gonna go ahead and do that. And so we have cosine of U, so we're on the blue diagram. The cosine of U is adjacent, so negative 15 over hypotenuse. Cosine of V, now we're on the pink diagram. The pink is the adjacent, square root of 7, over hypotenuse, which is 4, and then plus, and now we're back to the blue diagram for the sine of U. So the sine of U is negative 8 over 17. And then the sine of V is opposite, 3 over hypotenuse, 4. All right, and then we're just going to go ahead and we're going to simplify that. So then I have negative 15 square root of 7 minus 24 all over 17 times 4 is going to give me 68. So I don't need to find out U and V, but I've calculated the cosine of the difference of U and V. Okay, so we're going to continue on then with the second half of 5.4. So this is kind of like our day 2 of lesson 5.4. Okay, so this one here, we have inverses now as well, and we want to find the value of this, but we're not going to be using our calculators. We're just going to evaluate with what we have, okay? So none of the questions in here are we going to be using our calculators. So this one here kind of starts off into bridging into the next example, because here we do have unit circle values. And so one thing that we need to remember is that when we find an inverse, right, so this inverse, this is always representing an angle. And this inverse also represents an angle. So you always want to keep in mind that an inverse represents an angle, okay? Because then that sometimes kind of helps you figure out what you're supposed to do with each of the questions. Okay, so since these are unit circle values, I can simply figure out what is the angle on the unit circle, and then I can just go ahead and I can add them together. So let's go ahead and do that. So here this is going to equal, we have the cosine on the outside, and so I look first at this one, inverse cosine of negative 1/2. So inverse cosine of negative 1/2, if you want to say, okay, well, like we call that theta, and this you definitely wouldn't have to write down, but this is what you're thinking in your head. Well, theta is equal to the inverse cosine of negative 1/2, so that means that the cosine of theta is 1/2, and you're thinking about, okay, well, where on my unit circle is the cosine equal to 1/2? And you're thinking about also your restrictions as well. Okay, this is just a simplifying problem. So where the cosine is equal to 1/2 based on the restrictions, we have that that angle is going to be 2 pi over 3. Okay, and then, no, not 2 pi over, I lost my negative. Oops, it's a negative 1/2, and I wrote cosine theta equals 1/2. Negative 1/2, so we get 2 pi over 3. There we go. Confused myself there. All right, and then the second one again, and again, you're thinking in your head that that's an angle, so if you want to call it like alpha, what your brain is thinking is alpha is equal to the inverse sine of, there I go, putting negatives where they're not supposed to be, not negatives where they're supposed to be. All right, inverse sine of 1. And so then I have that the sine of alpha would equal 1. So I'm thinking about my unit circle. Again, I'm also thinking about my restrictions. So where does the sine equal 1? That is at pi over 2. And now, since I was able to find those angles, I can just add those together, and I can say, okay, well, that's going to be then the cosine of 7 pi over 6, which is, again, unit circle. So then I'm thinking about cosine of 7 pi over 6. So what's the cosine of 7 pi over 6? All right, very good. So negative square root of 3 over 2, and there we go. Okay. So we're kind of thinking about this represents an angle. This represents an angle. All right. It just happened that these were unit circle values. Okay. But really, this is just like finding what's the cosine of, if I called that first angle theta, so what's the cosine of theta? And then I called that second angle alpha. What's the cosine of theta plus alpha? And so if I would have taken that and plugged it into the cosine formula for the cosine sum, and let's see what happens then. If I would do the cosine theta cosine alpha minus sine theta sine of alpha, and you plug in your values that we know, then you'd be able to get this exact same answer. So then it turns into a problem just like we did in number 3. So you could draw your triangles. Again, our triangles are unit circle values, so we wouldn't necessarily need the triangles, but you'd get the same answer of negative root 3 over 2. And this is the connection that we're going to make. We're going to use this idea here for when they're not unit circle values to do the next problem. All right, so number 5. Let's bridge this then into a problem that's not unit circle values. All right. So, just like we said, this here represents an angle. And so let's call that angle something. Let's say that this is going to be the cosine of, and we're going to call that angle theta. Okay? So we will let theta equal the inverse sine of 12/13. Okay? Plus, and then this other one here is going to represent an angle. And so we're going to call this something else. So we'll call that alpha. And so I'll say that we can, I'm going to leave a little bit of space because I'm going to draw a diagram in there. Oops, I didn't want to use that fat pink. So we're going to say then, let's let alpha equal the inverse cosine of 8 over 17. And so now basically it looks like a problem like problem number 3 that we did in the first part. All right, so we're finding the cosine of theta and the cosine of theta plus alpha. For my theta, I can draw my diagram. Okay. Because this is not an equation, we are going to use our restrictions. Right? So we're using restrictions. So the inverse sine of 12/13, that's going to be in quadrant 1. So in quadrant 1, I will draw my triangle. Sine opposite 12/13 hypotenuse. And that's a Pythagorean triple. Missing side of a 5 here. So that's 5, 12, 13. We do the same thing for the pink. And we draw our triangle. And again, we're using the restrictions. So we have a quadrant 1 angle, cosine adjacent hypotenuse. And we have a Pythagorean triple again. So what's the Pythagorean triple that we have here? Perfect. We have a 15 there, 8, 15, 17. And now we can use our formula and plug everything in. So here we have the cosine of theta times the cosine of alpha minus now the sine of theta times the sine of alpha. And we use our diagrams to calculate each of those missing pieces. So why don't you guys go ahead and try and calculate that on your own and see what you get for an answer. All right, so check your answer with my answer and also check your work to make sure that you have the appropriate work in there. If you skipped this step right here, that's fine. Okay, the second to last step there. Okay, so one more together. So here, the same idea as what we just did in number 5, but now we're looking at when we have variables in it. Okay. So we can start off by just redefining some of these. So I can say, well, let's let theta equal arc sine of x. And then we can draw our diagrams. And, all right, so we have our sine. So the x would be x over 1, so opposite would be x. Hypotenuse would be 1. And then you can go ahead and find the missing side for that. I'm going to let my alpha equal arc tangent of 2x. And so tangent is opposite over adjacent, so we have 2x on the opposite, 1 on the adjacent, and then we're finding the missing hypotenuse. So go ahead and find each of those. And then our problem here becomes, what is the cosine? Oh man, I did a lot of cosine problems. I should have done this one as a sine or something. So I end up doing the cosine of, then I have my theta plus the alpha, which will become cosine theta cosine alpha minus sine theta sine alpha. So go ahead and find those missing sides and see if you can start plugging in to see kind of where you're at. Alright, so you can check that we have the right sides, and then we're just going ahead and calculating from our thetas and our alphas. So just plugging in from here. I'll start to plug in on my screen so you guys can finish working it up and then check your answer. Alright, so we have all of those in there, which then gives us the square root of 1 minus x squared minus 2x squared all over, and then the square root of 1 plus 4x squared. And I don't believe that the book rationalizes, so we'll just not rationalize this and we'll just leave it just like that. And there we have it. And so then on the last one, all right, so error, little error here. This minus sign, it just appeared into a plus sign by accident. So let's make this plus sign should be a minus, so then this should be a plus and a plus and a plus. So I'm gonna adjust each of those signs there. All right, so adjust each of those signs. That should be alpha back in there. So this is a minus, so the formula is plus, and a plus. All right, sorry about that. Okay, so then last question I'm going to leave you guys to do, and then you can check your answer. So pause the video and continue working this one out on your own, and then play the video to see the solution. All right, so I'm going to say let's let theta equal inverse secant of 17/15, and that's going to be quadrant 1. So secant is the reciprocal of cosine, so it's hypotenuse over adjacent. So 17 and adjacent is 15, so my missing side is going to be 8. And then I'm going to say, well, okay, so that's going to be my theta here. And then I'm going to say, well, let's call the second angle alpha. So we're going to let alpha equal the inverse tangent of 8/15. And that's going to be quadrant 1 as well because it's positive. And so I have tangent is opposite over adjacent, 8/15, 17 triangle. So then simplifying, here we have a sine. So I do the sine of theta, the cosine of alpha, keep it the same, so plus the cosine of theta and then the sine of alpha. So you're just switching what you're going to do for sine and cosine for those two. And then we're just going to go ahead and plug in our information. So the sine of theta, I'll throw my plus sign in there to use my colors. So theta's in the blue. Let's go do the thetas first. So sine of theta is opposite over hypotenuse. Then I have cosine theta to also do from that one. Cosine is adjacent over hypotenuse. Next I have alpha, so cosine of alpha, so times cosine adjacent over hypotenuse. And then the sine of alpha, opposite over hypotenuse. And then I just go ahead and I calculate. So when I calculate, I end up with 240 289ths. And there is my answer. So check that with your work and see that you have the same thing. Thank you for listening.